Hi guys, welcome to Unreal Engine video tutorial series. In the previous videos, we had a brief introduction to Niagara particle system, and then we understood the fountain emitter template. We created the ns underscore fountain from scratch using the empty template, right? In this video, I would like to discuss the hanging particulates emitter template. We understand how the hanging particulates emitter template is set up behind the scene. So let's get started. I delete these instances from here. I right click and say Niagara system. I select the empty template here, say create. I call this ns underscore hanging particulates. You can see ns underscore hanging particulates Niagara system is created. I double click to open it. You can see that the particulates Niagara system is open. Here we have the empty emitter. You can see that nothing is emitting. You can see that. Now let's understand the module groups and the modules. So in the emitter update module group, we have the emitter state. We set lifecycle mode to self. Right here in the emitter state, we set lifecycle mode to self, which indicates that the particles handle their lifetime independently, right? Particles manage their lifetimes independently. Loop behavior we set infinite because we want the particles to be emitted infinitely. So loop behavior infinite. Here the particles are emitted continuously. Keep on the particles are emitted, guys. Next, loop duration we are going to set 2 seconds. So each loop lasts for 2 seconds. So loop duration 2 seconds. Next, we are going to set spawn rate to 50. You can see there is no spawn rate module here. So we click on the plus sign and select the spawn rate module. And here we set spawn rate to 50. So what is the meaning of this? 50 particles are emitted per second, right? 50 particles are spawned per second. 2 second means total 100 particles, right? 2 into 5 here 10. So 50 multiplied by 2 is 100, right? So 50 particles are emitted per second or spawned per second. So here you are seeing only one particle, right? But actually all the particles are spawned in the same place, so you don't see the difference here. Actually, remember 50 particles are continuously getting spawned in this place, guys. Okay, next we have to set the size, color, etc. So we go to particle spawn module group. In that we have the initialize particle module. You can see we have the initialize particle module. Here we set the initial status of the particles. Next, we set the lifetime mode here. Let's go. Lifetime mode we set random and minimum lifetime 5, maximum lifetime 8. Here lifetime mode we change to random. Minimum lifetime 5 seconds, maximum lifetime 8 seconds. So some particles stay for 5 seconds and then they are destroyed. Some particles stay for 8 seconds, then they are destroyed. So we are setting the random lifetime for particles here. Okay, next color mode we set direct set here, right? We choose the color mode direct set. We can define the color of the particle here, like I say orange, so particles are displayed in orange. If you want like pink, the particles are displayed in pink, right? So you can choose the particle color over here. If you want, you can have random particle color also, random hue also you can choose. At present I use direct set. Okay, next we can set the sprite size mode. Even if you want, you can set the mass. Okay, so we set the sprite size mode random uniform. Here we have sprite size mode. Here we choose the random uniform, and some particles we want in small size, some particles we want in bigger size. So 2 to 3.5. Okay, minimum 2, maximum 3.5. You can see we have the particle created here. Next, we are going to decide the shape location here. So I click on plus and say shape location. You can see particles are generated in the spherical shape here, in the spherical shape. I don't want in a spherical shape. Instead spherical, I choose to box or plane here. So box or plane. Now the particles are generated in the box shape, because here box plane mode is set to box. Box plane mode is set to box. I can change the box size here. Okay, so I change it to 4000 actually. 4000 in x-axis, 4000 in y-axis. In the z-axis I set 400. Okay, in the z-axis 400. So you can see that particles are created here and there. You can clearly see small particles are getting created. Let me reduce it to 400, 400, 400 and 400. You see the particles are getting created here in the 400 by 400 box here. Okay, and they stay for 5 to 8 seconds and they are destroyed. So they are hanging particles, right? Hanging, they are hanging here. After defining the shape location, next we add the curl noise force. So we move the particles randomly here and there. So that's the use of curl noise force. In the particle update, okay, already we have particle state where it is already having kill particles when lifetime is over. It is tick, you can see that. Here we are going to add the curl noise force, curl noise force, and you can see it needs a module called solve forces and velocity. So I click on fix issues. Okay, now what happens, you see that the particles are moving here and there. You can see that the particles are moving here and there. You can see that that is the use of curl noise force, curl noise force. So they move the particles randomly here and there. So noise strength I'm going to set here, instead of 10 I set it to 5. Okay, and noise frequency I reduced to 25, reduced to 25. So now the particles are moving less far, right? You can see here less frequency, less noise strength we have. So here I'm setting 5 and 25. Okay, if you increase the noise strength, you see if I change 5 to 100, you see how the particles move here and there quickly. You see that, right? Abruptly they are moving here and there. So that is the noise strength. Okay, you can, I'm setting it less, 5. Okay, next I'm going to add drag, a little drag. Drag means opposite force to movement, right? It is resistance to movement, what we say. So drag, I'm adding a module called drag. Okay, now drag is set to 1. You see they move and stop early. Drag I am setting here random 0.8 to 1.2, 0.8 to 1.2. So here I choose random range float, and here I set 0.8 to 1.2. Rotational drag we do not want here, so I'll set it to 0, because we are not rotating the particles here. They are just hanging here and moving here and there because of the curl noise force. Okay, you can definitely change these values as per your need, guys. Okay, understand which module does what. Okay, how any module affects the particles in the particle system. And then we change the sprite size, actually scale sprite size based on the lifetime. So I'm going to add the module called scale sprite size, scale sprite size, scale sprite size. Now here what happens, the particles are going to have initially the size of 0, and slowly their size increases. Their size increases to 1. Size increases to 1. 1 means what? That is initial size we have set here 2 to 3.5. So they go from 0 to 2 or 0 to 3.5. If you want, you can definitely increase the size. Uniform curve scale, you can take help of this. Okay, let's double it. Okay, 2. So here instead of 1 I choose 2. Now what happens, you can see slowly the particles are going to become bigger in size. You see here. Okay, immediately it disappears. We don't want it, should not be immediately getting disappeared. So particles should not immediately get disappear. slowly they should get disappear. So for that, which module we use, guys? We use scale color module. So I will use the scale color module. You can see I have added, and scale alpha. Scale alpha I use float from curve. Float from curve. So initially 1 and finally 0. So what happens? The particles are not going to disappear immediately. They slowly get disappear. So size increases. You can observe one of the particle. Okay, from this you can observe one of the particle. You will clearly understand what exactly is happening here. Okay, so if I save this, let me save this and come back to level 1. And if I drag and drop, you see we have the hanging particles. You can clearly observe here. You can see the hanging particles, right? I hope you guys are clearly understanding. Now, as per our need, we can modify this effect. We can modify this. So I go here. Let me adjust few things here. Spawn rate, I'm going to increase from 50 to, let's say, 300. So more particles are going to spawn. If I save this and come here, you will see more particles getting spawned in the scene. You see more particles are getting spawned. You can see here, right? And next, what I do in the initialize particle, I am going to change the size here. Instead of 2, let's multiply it by 3 times. And here also I say multiply by 3 times. Multiply by 3 times. Now the particles are going to be bigger in size. You see, particles are scaling very big. You can see, nice. You can see, and even here in color, viscosity I changed to 5 so that the particles should glow more. So viscosity makes the particles to glow more. You see, they are glowing. You can see, right? And then I want the particles should spawn everywhere here. So I change the box size here, 2000 in x-axis and 2000 in y-axis. So if I save now, particles appear everywhere here in the scene. You see, right? So hanging particles. And if you want, you can move the particles here and there more faster by changing the curl noise force here from 5 to 50. If I save, go back to level 1, now you see the particles will be moving here and there abruptly. You can see that, right? And slowly they are disappearing because of the scale color, right? So if I go lit and say game settings off and EB 100 to -1, and then I am going to change the sunlight, Control L and move down. So you see how the particles look in the scene. So that's the hanging particulates emitter, guys. So if I use the fountain, see fountain particles, right? So in the previous video we understood how we can create this fountain effect, and in this video we understood how we can create the hanging particulates. So if you see the difference between the fountain and the hanging particulates, what is the main difference you can observe? The difference is here in fountain we are using the velocity to move the particles up, and we are using the gravity to move the particles down. Whereas in hanging particulates we are not using the velocity and gravity. Instead we are using the curl noise force module to move the particles here and there, right? To make them hang here and there, right? That's what the main module which we are using. And shape location, here we are using the box, and here we have used the shape location sphere, right? So that's the main difference between these two, guys. I suggest you people to try both, okay? Understand each module and their properties. It's very, very important, guys. I suggest you to try the change the values and see what changes you can find in the effect. Okay, learning Niagara system is all about adjusting the values and observing the changes, guys. Okay, with that you learn a lot. So if I go to initialize particle, let's say I can choose the random range, different colors. So some particles should display in red color and some particles should appear in the cyan color like this. We can choose. You can see if I save now, come back to level 1, we'll have different color particles here in the scene. You can see that. So just sit and modify the values of the properties and observe the changes. With that you learn a lot, guys. Okay, I hope you guys have clearly understood. For this video tutorial, this much is enough, guys. If you like this video, hit the like button and share with your friends so that everyone will get benefited. In the upcoming video tutorials, we discuss more about Unreal Engine in depth, step by step. For more benefits and be up to date, do not forget to subscribe to our YouTube channel. Keep learning, keep designing, keep sharing. Thank you, guys. Thank you very much. See you in the next tutorial.